Okay, hello everyone, welcome back. So now we're continuing on with more manipulation of data frames, but this time in a slightly different context. We're going to use a different package called tidyr. So likely we'll need to install that. So if you don't already have it, we're going to need to install it. It's called tidyr. Whoops, spelled it wrong. Tidyr. All right, so go ahead and install that. And another thing that you can do, which we're going to be using in a second while I'm talking, is there's going to be a separate data set called Gapminder Wide. And let's get the link to that. I'll paste that in the chat. So you can go ahead and download that and place it in your data folder. Okay. So what we're doing now is going to be a demonstration of how you can change your data from what's called a wide format to a long format and vice versa. What's that? So for that, I'm going to move over this figure that you can see. Data can actually be in either way or a combination of both. So what's the difference? If you look over here, this is considered wide, and the exact same data set, exact same data, can be presented in this long format. So for this example, why don't we think of this as like student information, since we're all students at some point. Looking at this first column, you see ID. So you can think of it like student ID. And you can consider this as like assignment 1, assignment 2, assignment 3, and then some grades in there. So this is probably a very typical format that we see when we want to get a sense of what the data looks like. It's relatively easy to read. On the other hand, we also have this format here, where you can see the same information is now going to be in a long format. Instead of each of those columns or variables having a separate column, so they had 1, 2, 3, we're going to store all of the information that was in those cells just in one column. Okay. And in that case, once we do that, we're not going to have for each each row is going to represent a separate ID, but rather the IDs will get repeated. And instead, the name of the variable will have a second key or like a second ID that will tell us when the value is corresponding to that assignment in this case. So if I have a number here, what is it referring to? Well, that's the second student's assignment 2 grade. Okay. And over here, what's this? Well, that's the first student's assignment 3 grade. So you might be wondering, why do I even need this? There's a few reasons. The first is that actually the one on the left, despite being really easy to read and understand, it's not exactly how data is stored in databases. This is, if you've taken anything related to databases, we call this denormalized. This is actually the more preferred way that data is stored in databases in this longitudinal format. Aside from that, from practicality, why do I care? Turns out that a lot of the things that we do, such as data visualizations or doing any type of statistical analysis, machine learning, some of those tools are going to need one format versus the other. So in that case, if we're going to do something using the same data set and then we change our analysis strategy, we actually do need to convert between back and forth. All right, so this is actually a very good way to understand the differences and when to use them. Typically, you're going to use long format for most purposes. So most of the data is going to be formatted in long format, and that will be just fine for your application. However, there's many instances where you'll need wide format. Some of those include like correlational analyses. If you're going to run something called like a multivariate ANOVA, if you're ever going to do some types of tree-based machine learning models like random forests, principal components, etc. Right? So knowing when to use each format is important. You can understand that from looking up the specifics of the analysis you're about to do. But for what we're going to do, we're going to see how we can convert between the two. Okay. So hopefully within that time, you got that Gapminder wide downloaded and you installed tidyr. Right, so let's go ahead and load it using a library. Keep spelling it differently. And if you don't already have it, for whatever reason, dplyr as well. Okay. And let's take a look at our Gapminder that we have had loaded. We'll look at the structure just to see what it looks like. All right. And if you look at it, can we tell what is this? Is this wide or is this long? So the way you can tell if it's purely long is there's only going to be one column with all the values in it. The way you can tell if it's purely wide is that every row is going to represent a separate instance of something. So in this case, it looks like country or something like that. But as we can see here that, okay, oh wait, that's a challenge. I'm not supposed to tell you. What do you think? So challenge one, do you think this is purely a long format, a wide format, or is it some kind of intermediate?
It's wide format.
So there are parts that are wide for sure, because we have separate columns. But notice here that we have values that are repeated, which is going to be a hallmark of this long format. Oops. So it kind of has both, right? It has the multiple columns for variables, but also has that repetition. So we saw Afghanistan replicated a few times. So this one was what? Looks like it's an intermediate format, right? Yep, exactly. It's got features of both. And that's going to be pretty common as well, because making something in a purely long or purely wide format might be a bit difficult to get in the specific format that an analysis or a data visualization needs. It might also be difficult to look at. All right, so it might be in some intermediate format like we have here. All right, so now let's go ahead and practice how we can change from a data set that's wide into a long format. Okay, so this is where we're going to use that new data we just downloaded that was called Gapminder wide. So we're gonna load that. I'm gonna store it as this object called gap wide. And from that, we're gonna read it from CSV. Mine is saved in my data folder, and it's called Gapminder wide.csv. We also want to include this option. I'll put that on a separate line so you can see it, just to make sure that it's not automatically converting everything into a factor when we might want it as numeric. Okay. So I'm going to read that in. And then just as a reminder, an alternative way to read things in, although it's great to have the code, so it's reproducible in the future, is using this import data set, and then you can click on base.
Where to get this file? Gapminder.csv. I don't have it.
Oh, it's I put the link in the chat. It's scroll up a little bit in the chat.
Yeah, so download it and then save it into this
Yeah,
folder. Okay.
that's right. Okay. All right. And then to check the structure of gap wide, can run the str function. And we'll notice a difference in the original Gapminder is, wow, look at all of these columns. It's like there's a separate column for all of the possible years, along with life expectancy and population. All right. So this is wide. This is not the widest it can go, because you could technically separate again by year, but this is relatively wide because you can see that there's multiple columns for all the different repeated measures in here. All right, so the task at hand is we're going to go from wide to longer format. And let's go back to this figure that's in your notes. So right now, this is the current structure. We have data where it's going to be by continent and by country, and then different information. So GDP per capita is going to be across as different columns for every year. Similarly with life expectancy for every year. And what we're trying to do is trying to reduce the number of columns and combine those values into one column. So we're going to be using this function called pivot longer. And if you look at this, this is how this is going to work. Basically, you're going to get the pivot longer function and then provide it the link to your data. So for us, this is the gap wide. And then you're going to give it a vector of which columns you want to collapse. Okay, so for example, over here, if I have 3 columns, A1, A2, A3, and I want to collapse them to a single column, I'm going to specify them here. And then after that, the single column that you're going to collapse them to, what do you want to call that? What is the new column name? That's going to be where you specify it as key. Okay. And then finally, what do you want to call the column that's going to have the values of all of these collapsed columns? And that's going to be right here where you specify it under values too. So then you can see that when we start with this wide format, it's going to concatenate or stack the values of each column on top of each other, and then remove those original column names like A1, assignment 1, assignment 2, and then give it some key like assignments or something like that. And then provide another column with all of the values, or in this case, scores that we would have. So that's the goal that we're going to try to do right now. Okay, is that clear? Why we're going from wide to, or how we're going from wide to long format? The why depends on what we're trying to do with it. So maybe we want to run a regression model and it requires a long format. So that could be the why. All right. So let's try it. We're going to convert this to something called gap long. So that's what we'll choose as the name. And from here, we'll start with the original gap wide. And then, remember what the and then is? It's that pipe. Okay, so we'll get the gap wide data, and then we're going to use the pivot longer function. All right. And I want to, if you remember the first thing we have to do, let me make some space. I pressed enter to make space. I want to tell it which columns I want to collapse. So which columns do I want to collapse? Well, basically, I want to collapse everything except the ID value, the IDs. So the 2 columns that are identifying what all the data is about seems to be the continent and the country. So I want to collapse all of these, all of these, all of these. Okay. So there's a few ways that we can do this. The really long way, which I don't recommend, is to get each column name and list it here. So remember, we would provide it a vector with the column name. So you could do this like that one, next, that one. Next. Yeah, you see how long that's going to take? Let's not do that. So that'll take way too long. We can try to leverage some of the patterns that we see in this data set. So I want to collapse all of these, for example, all of these pop columns, right? So instead of typing everything, we can use this function that's called starts with, and then give it the pattern we're looking for. Starts with pop. Okay. So just by doing that, we're already going to select all of these columns. That's the same as inputting pop 1952, comma, pop 1957, comma, blah, blah, blah. Very convenient. Similarly, let's do that to the other two patterns that we noticed that we're trying to combine. So now we'll have another starts with. And I can put in life exp. That seems to be the pattern. Remember, it is case sensitive, so don't forget one of the E's is capital. And that should take care of all of these that start with life exp. And then one more. Let's get starts with, and then our GDP per cap. Okay, just in case I don't misspell it, I'm gonna copy that little pattern, right? Copy, and then paste it in quotes. Okay, so that should select all the columns we want. But if you remember from that little figure, we also need to tell it what's the new column name that all of these original column names will be stored in. Right, so after the calls, make sure the comma is in the right place. So it'll be after this part of the code. You'll have your comma. We're going to specify the names to field. And what do you want to call it? So we're going to call this the observation type underscore year, right? Because the pattern is some kind of observation like GDP, life expectancy, population, and then the year. So that's why I'm choosing to call it this. And then it's also going to make a collapsed column with the actual values in it. So what do you want to call that? That's going to be the values too. And we'll call it obs values. All right. So let's try it out. So I ran that. And let's see the structure of this gap long. Okay, so if originally, I'll just scroll up to see what the wide one was. Remember, we had all of those separate columns. Now we can see that we have just all of those got combined into one column. And you can see all the different values that specify the original columns of the wide format. You can also kind of get a more realistic view as if it was a spreadsheet just by clicking on the names, right? So like if I click on like gap wide, you can see what it looks like and where we're at now with gap long. See that? More repetition and then the values stored for each one. I would say shortcoming of using long format is when you start to combine everything into just like single columns is the units go away. This is pretty common in big data where things are stored as massive long data formats where you have a bunch of values, but now you have things like age and like income. All of that is stored in one column. So that's just one shortcoming of it is that you can't necessarily just get an average of this whole thing. It won't really make any sense. You're going to have to go back and then convert it to wide again. So of course, we're going to practice going back and converting it to wide just to see how that might happen. Okay. But any questions so far on the process or why we did this? All good? Okay. Let's see. Now, an alternative strategy other than this, the basic one was just literally write every single column manually. We said which ones we want. You can technically do this by specifying which columns you don't want, right? So that might be easier, might be less code. It's kind of ingenious. So I'm going to actually copy this, right? This is a copy, but instead of doing this starts with pop, starts with life expectancy, we're going to give it what we don't want. So if you notice from our gap wide, we were collapsing all of these except continent and country, the ID variables. So if I don't want something, I believe you covered this, but just in case, you can use the minus sign and then type in the name of the column that you don't want to include. Then comma, we also don't want to include country. And if you were to run this, you should get the same thing, okay? So the benefit of that is, wow, the coding was so much easier. And you'll start to develop your own coding style and notice these little tricks as you do this even more. All right, so going back to what I mentioned, let's see if we can try to,
A question.
oh yes, question.
So why did we collapse population life expectancy and GDP per cap in one, like no one cell basically? Yeah, this value. It doesn't look any meaningful data, I would say.
That's a good point. This could just be, the data hasn't changed. It's just the structure of the data.
No,
The
data is like, it's not there is an individual value for GDP per cap plus we collapse no in a the previous one, gap wide, I guess. Gap wide, no, that is fine. But
Yeah.
gap long, no, gap long, it's all three columns are into one. We collapse all three values in one, GDP per cap. Um,
It might look different because for some reason it added scientific notation over here, but it's the same
no,
number.
no, I'm saying that we have three separate value GDP per cap, 1952 for Algeria plus Algeria population and Algeria. What is the third
Oh,
value?
yes, it's down
Oh,
here.
okay. 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 Sounds good. Okay. Got it.
Sure. So yeah, that's a good observation that I think is another shortcoming of long format is it's hard to read. Um, this is more natural when you have it in a wide format.
Yes.
Yeah.
Mm-hmm.
But the reason mostly we do this for long format is just some analyses require it. If you wanted to run an
Yeah.
analysis like a linear model, you probably have to convert it to long format. So
Yeah. Sometimes reporting also, data
yeah,
warehouse.
that could be another reason. Yes. Okay. So let's see. What if we take a look at this? Let me check the time. I think we're good. And maybe I decided that, this gap long, I think it's maybe it's too long. Maybe I want to do something else. Okay. So maybe I want to keep it long, but just widen it a little bit. All right. So then maybe I want to separate some information. So let's try to separate some information. So I'll get my gap long and I'm going to overwrite it. See it? And then, right? That's our type. And then I want to separate it. And how do I want to separate it? Let's see. It looks like I have this obs type year that I want to split. Obs type year. And what I want to try to do is split it into two different columns. Okay. So I'm going to split it but obs type, oops, sorry, obs type and year. Okay. And how does it know how to split it? Well, we can tell it to split it based off the underscore. There was a reason why we had saved it with this underscore. It makes it a bit easier to go back later on. Okay. So if I run that, and then I take a look at gap long, what happens? Oh, look, it's still long, but now we're making it more intermediate. We added an extra variable. So we have observation type and year now split. So this allows us to kind of tweak it so that if we don't want to make it too condensed, we can then widen it just a little bit by separating it by one. Okay. So one issue though is you got to check because sometimes things happen that are very difficult to tell. Like just looking at this, I think it's fine. But if I were to double check the structure of gap long, we'll notice that year, oops, it thinks year is character data. So running down the line, you might be running an analysis, and for some reason you need year to be numeric, and then it might throw you an error, and you wonder what went wrong. So it helps to check after you do a data transformation, has the structure remained the same? Okay, in fact, we're gonna shortly do a function that will check everything to see if everything actually remains the same. But in this case, nope. It looks like gap long's year became character. You can see it as CHR, and the data is in quotes. So to fix that, I'm just going to specifically target the year and coerce it or convert it to an integer. Okay, you might have done this in a previous lesson. All right, so things happen when you're playing with the data, you're trying to get it in the right format. So it's always good to check to see if everything went as expected. So now when I run this, I'm gonna overwrite the year with year as integer now. I can check the structure again of gap long, and it looks good. Now year is in integer format, which I wanted. Okay. Any questions so far? Now, this is a review of your last lesson that you just took with Robin. Challenge 2. Okay. For this one, can you now use this new gap long data and then go ahead and see if you can get the average in a summary? So let me paste the challenge. So calculate the mean life expectancy, population, and GDP per capita for each continent. Hint. Let's see, question. So numeric is, let's see, numeric and integer. They're going to be different ways that data is stored. Integer specifically is whole numbers, right? Integers, you can't have decimals in these, I believe. And numeric is going to be a bit more flexible. Someone correct me if I just spewed out something wrong. Okay. And as you're doing this with the group by, think about what you're trying to group by. So it is part of the prompt. Good question. Typically, year is a number, it's something you don't get the average of. So I don't expect ever to get like decimals in there. But if I ever do, like for example, age, was stored as integer. And like, it makes sense. I can have age as like 20.5, 60.1. Then I can convert it to numeric. So it just depends on the situation. If you do want it to be more flexible. With bigger data sets, sorry, neighbor kids crying. With bigger data sets, when you choose more concise data types like integer, when you know your data will never change and have decimals, for example, it actually saves a bit of space in the long run. With smaller data sets, you probably won't notice anything. Sure, you're welcome. Okay, why don't we try this out? So let's start with original data, gap long. And how do we aggregate again? We want
Mean
group by, right?
a group by, yeah, group by, but
Yep, group by, and whatever we want. In this case, you want it for each continent. Okay. However, we have something special right here. If you notice from the structure down here of gap long, that if I just go ahead and get an average of the numeric types, it's going to think everything is the same. So we actually need to group by one more thing. Does anyone know? So just so we split it. So we know that we're not going to try to average life expectancy and GDP. We need to split one more time. What's the second group by? It's going to be the OBS type. Yes, very good. And why is that? Because we saw that the OBS type is going to have it's going to specify when it's GDP, when it's life expectancy, when it's population. So when you group by that, that should allow us to get what we want. What am I doing? OBS type. All right. And then we can summarize and have our means, I'm just calling it means, come from the function mean of our observation values. All right. And let's take a look. And there we go. Look at that. We're able to get average of each observation type for each continent. Isn't that interesting? Right? Okay. Now let's see how we can go backwards even more. All right. So meaning we're going to go, we went from wide to long. Let's go from long to wide. And with that, there's a few ways that we can do this. So let's see if we can go back from long to intermediate, meaning exactly the same as Gapminder. So we're going to try to go back to be the same as Gapminder. Gapminder is like in the middle. It's not fully long. It's not fully wide. Let's try that. So I'll call this gap normal, meaning I want this to be, we're trying to replicate what we have in Gapminder, an intermediate type of data set. Okay, and what I want to store in there is this gap long that I've been working with. And then I want to make it pivot wider. All right, pivot wider. So with the pivot wider, that's going to be a little bit easier to do. Making something wide is going to be a little easier than making it long. First, we want to know, because we're going to split into multiple columns, right? We want more columns. So where are the column names coming from? Where are these column names coming from? Looking over here, these are, not this one. These are all the column names, right? In observation type. So they're going to come from obs type. And then each column will have some values in it. Where do the values come from? Well, that one's not too bad. We have a column already that specifies where the values come from. So the values are from obs values. Let's try that. All right, so we've made gap normal. Already you can see that gap normal has a similar dimension. So 1,704 rows and 6 columns. Same thing as our original gapminder, 1,704 rows and 6 columns. You can also use the dimension function, dim, just to check. Okay, so far so good. We can see, does that match the same as the dimensions of gapminder? Yep, same thing. So 1,704 rows, 6 columns, same thing. What about the names? Right. Basically, we're verifying if a data transformation worked properly. So if I look at the names, that looks right. How about the gapminder? Okay, seems good. It's out of order, but seems mostly good. So it seems like everything's working. Why don't we try an even more detailed approach to really check, are these the same? So this is a good exercise to do. You know you need to convert something either from long to wide or wide to long. And if you back transform it, meaning try to go backwards, can you get the same thing? Then that's kind of verification that the data set was properly transformed. It'd be terrible if for some reason that it did not go through right, and then you spent a year working on a data set that was improperly transformed. You're trying to publish a paper, you get a question, and then oops, turns out all this time something went wrong. So this verification process, although kind of tedious, it can be really important. Okay, so let's try to make this a little more automatic. What I'm going to do is I'm going to make sure that the gap normal data set is in the same order of column names. So same data, but I'm going to make sure the order is the same. So what I can do is a little trick. All right, it looks like I'm just giving it to itself, which is kind of true. So remember with this bracket select notation, everything to the left is the rows, everything to the right is the columns. So I want to keep all the rows, no problem. But on the right, I want to make sure that it's going to be the same order of names as the gapminder. So if I select the columns, if I select the columns that according to the names of the gapminder, then it's kind of like I'm shuffling the columns so that it's in the exact same order. All right, so that's what happened. And now I want to do a really thorough check. Are these exactly the same data? So imagine that I'm transforming a data set, then I really want to check, I back transform it, double check, is everything equal? There's a function called all equal. Okay. And basically you just plug in the two data sets you're trying to compare. So I want to compare the gap normal with the gapminder. Please be the same. Found some mismatches. Wonder why. What's going on? So I can check this in a few ways. I can click over here, right? I can check gap long and then gap wide, or within the code, I can do the head function just to kind of see what's going on. Is it really that there's something wrong, or maybe it's just out of order or something like that? Okay, so this is going to be the first 6 rows of gap long. And this is the first 6 rows of gap minder. Oh, the order is different. How am I going to fix that? Well, I can arrange it. Okay, I'm going to arrange it so that it's in alphabetical order and numeric order of country and year. All right, that should work. So now we're going to do a little bit of arranging. So for gap normal, I'm going to, again, feed it the same thing, gap normal with one exception. And then I'm going to arrange it, so sort it, by country and year. Okay, so now let's check, is it the same? Okay, so all of those other errors went away. We have this one final error that says class mismatch. It turns out, though, that it's not a big deal. What do you mean? It says there's a mismatch. Well, class, let's check. What is the class of gap normal? It's a tibble. What is the class of gapminder? It's a data frame. That's not a big deal. So none of the data itself was different. It's just saying that one's a tibble, one's a data frame. That's not any issue for us. They're virtually the same for our purposes. If you really, really want, you can convert your gapminder, or at least check it using as tibble. And then you'll say it's completely the same. But that might not do anything extra. I mean, it's just really, if you want it exactly the same format. But the fact that none of the data was actually different, it didn't give flags like this one, that there's differences in the averages or anything, then that's a good sign. We were able to convert all of the things that we were trying to convert, and we can breathe fresh air. Okay. Any questions about what we've been doing so far? Oh, good. Let me just check the time. I might be talking too fast. I am talking too fast. Okay. So
Yeah, actually, we want to also try it out, and it's very hard to catch the speed basically when we are trying and understanding from you and then trying by ourselves. It doesn't sync basically.
for sure. There's definitely a lot of things that that need to be done in the process. I think the main takeaway from what I've been doing right here is always check. So when you have a data set, it's probably not going to be exactly the same format as this gapminder. Things to take away at this point is that if you need to make it longer, if you need to make it wider, then we're going to be using this pivot wider function. If you need to make it longer, then you can use this pivot longer function. And sometimes you can even make it just a little bit longer by using a separate function. And I think that's the main things at this point. We're definitely going to have a little challenge to work on in a second. But the next thing is, what if I want to make it just a little bit longer, right? So by separating, we went from something that was long, we made it a little bit wider. What's the similar situation if I want to make something just a little bit wider or longer? Well, what we're trying to do then is combine different columns. And what we can do is use the unite function. All right, so I'm going to make a new one that's like about intermediate again. I'll call it gap temp. And with that one, I'm going to provide it with the data and gap long. However, and then I want to unite it. What's that? Okay, now I'm going to try to combine different columns together. All right, so then let's see. If I look at gap long, that looks like this. Let's try to combine, how about continent and country? Make that just one column, combining continent and country. All right, so using unite, I'm going to say I want to create a new variable. I'll call it var ID. Okay, so this is a new variable I'm trying to create. It's going to come from continent and from country. And I want to add a little separation between them. So typically what we do is we can add a little underscore. So separate it by an underscore. Okay, so looking at this gap long one more time, you see continent and country are going to be two separate columns. What this should do is it's going to combine continent and country into this new variable, new column called var ID. Okay, and let's check out the structure of that. And looks like it worked. All right, so it just got a little bit longer. Now, what if I want to go even more? Okay, so what else can we combine? Maybe I want to combine the year with the observation values. So combine those together. Well, we can do the same thing. I'm just going to copy this part right here. And if I want to combine it even more, well, I can just type in or say, and then unite again. And what can I call this? Why don't I call this var names? And I'm going to combine obs type with the year. And make sure it's separated by something so it could be a little bit readable. Similar to here, how we combine continent and country, and it was separated by underscore. What this is going to do is it's going to combine our obs type and our year, and then separate that with an underscore. Okay. And now when I check out gap temp, you can see that we've now combined it even further. So there's less columns, more long format. All right. So far, so good. So just to recap on some of what has been going on is we can recognize when something is in a wide or long format or intermediate. If we need to make something longer, we can use the pivot longer. Just gonna scroll up real quick. Right. We can also try using separate. If we need to go wider, we can do pivot wider. Or you can do using unite. Okay, so those are the main things so far. Now, from here, maybe if you want to make another wide variable, we can also do that here. So let's say that I want to make a new data frame called gap wide new. Just calling it gap wide new because we already have a gap wide. And I'm going to start with gap long. And for this one, let's have a combination, right? So you saw where we had gap wider, or sorry, pivot wider or gap long. Let's try combining both, okay? So in this case, let's try making a new column called ID bar, where it's going to unite the continent and the country. And it's going to be separated by an underscore. So this is exactly what we did so far, right? Just like in this example above. So that's going to collapse continent and country together into a new variable. And then also collapse var names, make a new column called var names. And then that's going to collapse our obs type and our year. So again, similar to what we've been doing so far. And now let's combine it even further to make it a pivot wider. All right. So this is making a combination of making some things long and then some things wide. All right. So now we're going to pivot wider. And with pivot wider, that we're going to start to create more columns, right? So we need to know what are the names of those columns. And the column names are going to come from the var names. So this is an example that I feel like I wouldn't do like out in the wild, meaning like this is something I probably wouldn't do on a typical analysis because we're kind of like going back and then forward. But this example is meant to demonstrate the flexibility that you have. That if you really need something custom where some parts are long, some parts are wide, you can do that by using a combination of these. Okay. And now we're going to get the values from this, the observation values. Okay, so a combination of using unite and pivot wider. And what does this look like? Okay. Does this look familiar? So we have a ton of different columns. This is nearly the same as the Gapminder wide data that we downloaded. Okay, so showing you how much further you can go to make something a wide data format. All right. Questions so far? So far, so good. Okay. Let's see. I get out slightly early. That was where I wanted to stop. I kind of expected more questions, to be honest. Maybe if let's see. I just want to double check just to see the takeaways that you get. Do you feel confident that you know the difference between wide and long formats? Yes, okay, great. Do you see when what exactly is happening when something is going from wide to long? So basically what we do is we have many columns, and now we're stacking the columns together and combining columns into single columns, how we get to long. Yes, okay, great. And then finally, does it make sense when we want to convert back from long to wide? We're going to, now that we have everything in a single column, we need a way to create new columns for every different value, or sorry, every different column key. So that's why in our code with pivot wider, it's asking you, where am I getting the names from? And where am I getting the values from? Okay, so going backwards. Those are, I think, the main takeaways from this part. Oh, sorry, I missed that question. Okay, so yes, so right here, we are going to unite continent and country. So originally we had 2 columns, which was wider, and then they get collapsed into 1 column. Yeah, so it gets longer. Yep, that's right. The separator. So for example, let's take a look at gap wide new and gap long. So gap long is this one. We had continent Africa, continent or country Algeria. And then when these get combined, we want a way to kind of preserve the separation. So if you don't put a separator, it's just gonna like it'll just say Africa, Algeria without any space. But just to make it a bit more readable, if we put that separator, it's going to add the underscore. So it's just a little bit easier to read. And why do we do that? Besides make it easier to read? Well, should we want to expand this and again, make it wider one more time, we can use that underscore to have it split at that point. And then that way it make it a bit easier in the future if we wanted to make it wider again. Sure, you can use different symbols. Want to try? Let's try a different symbol. See? Now we have a plus sign. Any more questions? Yes, it is the opposite of unite. Exactly. So maybe we would want to separate this in the future. That's why having this little character there will make that easier, should we want to separate. If it doesn't have a separation character, hopefully there's some kind of pattern. So for example, here it's pop, right? So then I can separate it based off that starts with pop. It's gonna be a bit more complicated though. It's possible, but you might have to use something called regular expressions where you're trying to look for patterns and then tell it what is this position you want to split it at based off some kind of pattern that it has. But it is still possible to separate if it has no special separation character.